This is the story of the one. As head of maintenance at a concert hall, he knows the show must always go on. That's why he works behind the scenes, ensuring every light is working, the HVAC is humming, and his facility shines. With Grainger's supplies and solutions for every challenge he faces, plus 24/7 customer support, his venue never misses a beat. Call quickgrainger.com or just stop by. Grainger, for the ones who get it done.
Welcome back to the Deep Dive. If you thought the world of AI was moving fast before, well, the news that dropped around September 19th, 2025 really proves we've hit true escape velocity. This wasn't just a collection of minor updates. This was a high-stakes, high-velocity collision of innovation across infrastructure, consumer tech, and even, believe it or not, the fundamental ability to engineer biology. Our mission today is basically your shortcut to being well-informed. We're cutting through the sheer volume of announcements and, extracting the most critical nuggets of knowledge, where AI is actively being built, deployed, and what it's actually achieving right now.
And that mission is particularly vital because our sources reveal a simultaneous acceleration across three really distinct vectors. We're seeing these massive financial and infrastructure commitments determining the future compute power, right? The power needed for the next generation of models. We're seeing AI leap from the cloud onto consumer hardware, onto your face, your wrist. And critically, we're seeing true scientific breakthroughs that are redefining what a model can actually accomplish. These are all sort of paradigm shifts happening globally all at once.
Okay, let's unpack this. And we really have to start with the money and the muscle, the huge strategic moves that determine future AI capacity. This is all about infrastructure and power. And the biggest story here involves Nvidia, which made two massive and maybe sometimes surprising power plays.
That's right. The first move demonstrated that even the current, king of chips recognizes the need for structural fusion to maintain dominance. Nvidia is investing a staggering $5 billion in Intel, kicking off a broad strategic partnership.
$5 billion into their historic rival. Why is that financial commitment so profound beyond just the headline number?
Well, because it's a commitment to blending their core competencies. They're going to co-develop new data center products. Think custom by 86 CPUs tailored specifically for NVIDIA's AI platforms, and even new by 86 RTX SoCs for consumer PCs, essentially fusing NVIDIA's GPU chiplets right into Intel's hardware stack.
Wow.
The insight here is that neither company believes it can dominate future scale alone. So they are, strategically necessary partners now. And the mechanism for connection is critical. They're using NVIDIA's high-speed NVLink interface.
Oh, NVLink, right.
Think of NVLink as NVIDIA's lightning-fast data pipeline. It makes sure data and control code can fly between those different processors much, much faster than traditional buses.
Okay. And if that wasn't enough, they made a second move specifically aimed at massive scale networking. They spent over $900 million on what is technically an acquihire of key employees and licensing the semiconductor interconnect technology from a firm called Infabrica. What is the immediate goal of that IP?
It's all about extreme scaling. That core technology is essential for connecting over 100,000 GPUs into a single cohesive network. The sort of fabric required for those truly massive world-scale training centers.
100,000 GPUs.
Yeah. And what's fascinating here is the acquihire, tactic hiring the talent, and licensing the IP instead of a full acquisition. It's a calculated speed move. It shows just how desperately they are rushing to lock down the core network IP, prioritizing velocity and immediate implementation over, say, the expensive regulatory reviews a full merger would require.
That focus on strategic speed connects directly to national security, doesn't it? While we're discussing infrastructure, Scale AI just landed this massive $100 million 5-year national security contract with the Department of Defense's Chief Digital and Artificial Intelligence Office, the CDAO. This is a huge government commitment.
Absolutely. This is hailed as a game changer because it successfully bridges commercial innovation with the highly sensitive, classified environment of the military. They are providing the scale data engine infrastructure, which turns the DoD's raw data into an AI-ready asset. And crucially, they are providing the scale Gen AI platform. This allows the DoD to test and fine-tune generative AI models using their own classified information, all in secure, controlled environments, of course.
And what about the third piece of that contract, the Scale Donovan platform? Why is that crucial for the DoD's operations?
Donovan. That's their specialist platform for mission-tailored AI agents. It lets analysts sift through huge volumes of unstructured data to enable decision-making at mission speed. meaning it drastically accelerates how fast they can move from data ingestion to actionable intelligence.
Right, okay. And while the U.S. is busy integrating scale AI into the national security apparatus, this infrastructure power play has global friction points. One notable nugget from our sources is China's internet regulator banning major tech firms like ByteDance and Alibaba from purchasing Nvidia's AI chips.
That's a direct geopolitical move.
Yeah.
Yes. It's an aggressive push toward forcing the use of domestic alternatives. It definitely heats up the tech race significantly by making it harder for China's own champions to access the globally dominant compute power.
Okay, so that's the high-end data center battle. Now, let's pivot. We've established the hardware is ready, the money is flowing. Let's look at how AI is moving from the dark, cold server room right into the hands and, well, the faces of users. We're talking consumer experience, and we have to start with OpenAI's ambitious hardware rumors. Reports suggest OpenAI is developing its own consumer hardware, targeted for late 2026, maybe? Looking at a range of devices like a smart speaker without a display, glasses, a digital voice recorder, and maybe even a wearable pin.
Yeah, and they are taking these hardware ambitions seriously. They're securing contracts with major Apple suppliers, specifically Luxshare and Gore-Tex. And they've already brought on hardware employees from Apple. They put their former product design head, Tang Tan, in charge of the effort. It's clear they want a direct line to the consumer experience, one that isn't filtered through, say, Google or Apple's own operating systems.
Right. And while OpenAI is planning hardware, Meta is launching it. They announced the $799 Meta Ray-Ban display smart glasses. They put a built-in screen right on the right lens for things like directions and alerts.
But the control mechanism is the truly novel piece of tech here. These glasses are controlled by the Meta Neural Band. It's a screenless wristband that uses electromyography.
Electromyography, EMG.
Exactly, EMG. It reads the tiny electrical instructions your brain sends to your hand before you even move it. That's how you navigate applications, without actually touching the glasses or even speaking a command. It's a huge step toward seamless interaction, even if this initial consumer version is apparently less capable than their top-end Orion prototype.
Interesting. And as hardware moves forward, software isn't standing still. The immediate impact on the user experience comes from Google adding Gemini directly into the Chrome browser for Mac and Windows users in the US.
This is a massive utility boost because it integrates the power directly into your primary workspace, right? Your browser. Users can now ask the AI for help understanding the contents of a particular web page, or assistance when they're working across a number of different open tabs, or even help with very granular single-tab tasks like scheduling a meeting based on the page's content, just right there in Chrome.
Okay, so we've covered deployment and access. Now, let's ask, what can the models actually do? Section 3 is about the ascent of model intelligence and creativity, where models showed they are moving far beyond simple, predictable tasks. And the most stunning results came out of the ICPC World Finals, the International Collegiate Programming Contest. This is where models have traditionally struggled with multi-step algorithmic reasoning.
The results were genuinely shocking. Really defying previous expectations for AI performance in highly abstract problem solving. OpenAI's GPT-5 achieved a perfect score, solved all 12 programming challenges, and submitted the correct answer on its first attempt for 11 of them. Just incredible.
Yeah, 11 on the first try, wow.
And not far behind, Google's Gemini 2.5 DeepThink earned a gold medal by solving 10 of the 12 problems, including one that actually stumped all the human teams competing.
That is insane. They're not just writing code. They are demonstrating complex, creative, multi-step reasoning capabilities. If AI can beat humans at abstract, multi-step algorithmic problem solving, well, what does that mean for the entry-level engineering job market? This feels like a fundamental change in cognitive labor.
It absolutely is. And that movement toward reasoning-powered models extends to media creation, too. Luma AI released their Ray 3 video model, which they're calling the world's first reasoning video model.
Ray 3 generates native HDR video, okay? But the standout feature is that reasoning capability you mentioned. It allows the model to understand nuanced directions, evaluate its own generations, and actually iterate automatically until the outputs meet the quality standards specified by the user.
Exactly. It essentially self-critiques its way to a better result, like an editor built right into the creator. They also introduced visual annotation controls, letting creators sketch directly on their frames to guide movement and specific camera angles. And for speed, the new draft mode allows for generating rough previews in just 20 seconds, at like 1/5 the cost, before upgrading selected shots to full 4K HDR quality in under 5 minutes. That brings unprecedented speed and customization to high-end video creation.
Okay, from generating cinematic video, we shift to gears to maybe the most critical area, high-stakes breakthroughs in science and health. This is where AI truly starts designing life itself. Researchers at Stanford and the Arc Institute just achieved a phenomenal breakthrough. The first AI generated entirely new viruses that successfully infect and kill bacteria. They designed life from scratch.
That phrase alone is stunning, isn't it? This is foundational computational biology. They trained an AI model called EVO on 2 million viruses, then tasked it with designing new ones. Out of 302 attempts, 16 proved functional in lab tests, and those functional AI viruses contain 392 mutations never before seen in nature.
Incredible. And the functional results were even more startling, right? The AI-designed versions broke through defenses when bacteria developed resistance to natural viruses that traditional ones failed to breach. And get this, one synthetic version successfully incorporated a component from a distantly related virus, a component researchers had tried and failed to engineer into a working virus for years. The AI succeeded where human experts couldn't.
The implications here are massive, especially for the future of antibiotics and, well, biology control in general. Which brings us directly to predictive healthcare, showing how AI is reshaping diagnostics. European researchers developed the Delphi 2M system, which is a major step toward proactive medicine.
What exactly does Delphi 2M do?
It analyzes medical records to calculate individual disease risks across more than 1,000 conditions. Looking up 20 years into the future, it studied health data from 400,000 UK patients, learning patterns from visits and hospital stays, and was then verified on 1.9 million Danish records. It provides a complete simultaneous risk profile across 1,258 conditions, allowing for a far more proactive approach to health rather than the reactive treatments we usually see.
That's amazing scope. And Johns Hopkins researchers applied AI to surgery risks, achieving 85% accuracy in predicting whether patients might suffer strokes, heart attacks, or death within 30 days of surgery. An 85% accuracy rate at spotting deadly risks is better than many human assessments, surely.
Well, they trained models on routine electrocardiogram, ECG, data from 37,000 surgical patients. They used a fusion model, which combined the ECG data with simple patient details like age and gender, and it significantly outperformed traditional risk scores. This shows AI can pull life-saving insights clues about inflammation and metabolism from routine preoperative tests that clinicians already perform but don't currently analyze at this deep predictive level.
Wow. Okay, finally, we need to touch on the economic friction emerging across the AI landscape, the tension we're calling the AI paradox. The prime example is Reddit. They are apparently renegotiating their AI partnership with Google, seeking to replace their current flat fee arrangement with a dynamic pricing model.
This is a massive leverage play, yeah. Reddit is using reports showing them as the most cited domain by AI models to argue their archive of human conversation is severely undervalued. The dynamic pricing model is their hedge against the AI paradox.
Which is where Google's AI overviews summarize answers, reducing the click-through traffic that Reddit relies on for its advertising business. So the platform that helped train the AI is now being undercut by the very service it created. Is this going to be the central legal battle of the next 5 years, the creator versus the collector?
It absolutely feels like it could be. This negotiation establishes the precedent for whether platforms that host human-generated training data can command a share of the resulting AI economy, or if they will simply be rendered, somewhat obsolete by the very intelligence they fueled. The industry is watching this very closely.
Okay. To wrap up our findings, let me quickly share just a few final nuggets that came out of the roundup, painting a picture of where the industry is heading. First, Anthropic CEO Dario Amodei now publicly states he believes there is a 25% chance things go really, really badly, with AI development leading to disaster.
Wait, a 25% chance of disaster? From Dario Amodei, one of the industry's ethical leaders. That is not a rhetorical number. That's a major statement. It signals that even those closest to the cutting edge are quantifying serious existential risk, and it really demands attention.
Duly noted. Serious stuff. What else stood out in the final roundup?
Second, the DeepSeek R1 model's technical paper revealed its surprisingly low training cost, just $294,000. This is a powerful indication that the cost barrier to entry for highly capable models is dropping rapidly. The ability to build large, capable models is democratizing far faster than may be expected.
Okay.
And third, Notion launched Notion 3.0, featuring AI agents that can now complete multi-step workflows, access integrated tools, and work autonomously for up to 20 minutes at a time. This signals the start of true extended agentic capabilities moving into common enterprise software.
What an incredible density of news. If you synthesize all of this, what we are seeing is that AI is moving from a theoretical concept, something you read about, to an unavoidable physical and structural reality. Whether that's in hardware, global finance, or the ability to engineer life itself, the foundation is being laid incredibly rapidly beneath our feet.
And that leads to the final thought you should mull over, strictly informed by the source material. That breakthrough in designing viruses, as the Arc Institute eloquently put it, shows the transition from reading and writing genomes to designing them represents a new chapter in our ability to engineer biology at its foundational level. So what is the true scale of impact when intelligence moves from passively understanding the world to actively designing its core components? That change truly affects everything.